Hi guys, welcome back to the shop. Hey, today we're going to get on the boring of the HS1 90cc twin cylinders. I've already got one done, so it'd just be the one, but it's kind of a different process than I've done in the past. I think some other folks may do this, but I don't like to use a boring bar on a milling machine for this reason, or for this for boring. But in this case, it worked out very good if you do if you select the right stuff. So I'll kind of go over what I used and why I used it, and we'll go from there. But I haven't set anything up yet, but since I did one yesterday, I've got all my stuff together and I know what I need to do and how I need to set it up. So I'll take you along on the journey. We're boring 10 thousandths out of the cylinders. That's the first oversize, and it really doesn't take very long to do it. They're very small, and even taking light cuts, it just doesn't take very long. But the problem is you can't see much because the holes are so small. Let me get you around here and we'll take a look at what we're going to do and how we're going to do it. Okay, I just want to go over, this is what I usually use for boring most of my 125s and up to about 2.5 inches or something like that. I use this, and that's because I can get this whole boring head in the cylinder. It can go straight through. I use the Mesa tool short boring bar that's really beefy. This is 3/4, and it's made. It's got two positions that it takes up in the boring head, and this, like I say, is a 2-inch boring head. And this works real good for that size cylinders. If I was boring these cylinders, which are very small, you can see here that there's no way this boring head is going to go in there. See, it just won't go. Now, if a fella had a smaller boring head, he might be able to use that, but those are really expensive. So in this case, I would have to remove this boring bar from my boring head and insert a boring bar. And I'd put it in the center hole here probably. So that way I could get all the way through my cylinder. Okay? But the problem there is that this is 1/2 inch, and you'll get a lot of flex out of this at the end of 6 inches like that. So to get away from that, I'm using a 3-inch boring head. This is it here. It's a DBL 203 Criterion, and I use a 3/4 inch 6-inch boring bar, and that's a lot more rigid. And the only thing is this, this obviously is not going in there either, but you've got to watch your setup so you have enough to get through. And I've just barely got this. I think I've got about a 1/4 inch clearance. But this gives us a lot more rigidity. And you notice here I'm using the center hole. These things, they'll have 2 holes here generally, and this one here takes up both holes with this boring bar, just because it's more rigid. But in this case, I can't use something like that. So by using a 3/4 inch hardened, and because it's hardened, it's even more rigid than just mild steel. we're able to go through, and on the first one I did, I had absolutely no taper. It read the same on the bottom as it did on the top with a micrometer. So I was very happy with that. I really expected to see a little taper, but I didn't, and I think we can say that's because I generally don't go more than 0.02 per cut. And we're only going 10, so we're about 5 cuts, five passes through. So just with that little explanation there, then we'll go ahead and start setting this up. Okay, since we've got to set everything up, I've got to remove the boring head. Just to show you here, we got the 2 holes, and I'm using the center hole. Use the outside hole if you're cutting bigger, and if you're cutting even bigger, you'd put your boring bar in here, and it would stick out this way, and you'd even have a bigger cut. But I used to do most of these little boring, little cylinders. I used to do on the lathe by making a jig to set it all up in, but it's really time consuming, and this is my new gold standard pretty much. This is what I use now for the smaller ones. Okay, I've got 1, 2, 3 blocks. These are the ones that I've marked for doing this because they're exactly the same. The measurements are. I've got some cheaper ones like these here that I don't use for precision work. I just use for spacing. So these will set down. I've already made sure that the table on the milling machine is clean, and I've already made sure that the bottom of the barrel here is clean. So you don't want to leave any gaskets on there. You don't want to leave any have any dirt or anything that could set this off to one side or the other. So we'll just go ahead and we'll set this up just like we generally always do. And then we'll get this set up so we can clamp it down. Get in here as close as we can. Okay, I think we're bolted down, and I use this one over here to help with my indicator here. So we need to get it mounted next, and we'll do that with a collet, 3/8 collet. And that'll just go in there. All right, so okay, try to center the coaxial indicator the best you can. Just trying to get it this way and this way. Just an eyeball thing over the hole. That's probably pretty close. We'll just pull this out to give it a little spring, and then we'll get it back in right at the top where there's no wear, hopefully. And you'll see now why I put this longer stud over here. Is this little piece right here goes in, screws in right here. Just, you got another one over here on this side. And it just bangs up against that to stop this whole thing from spinning around, so you can see the gauge. And then we kind of spin this to get it close. We're off quite a ways here. Okay, that's close, so I can go ahead and turn the machine on. Okay, we've got the machine going here now, and now we'll just kind of work this. That's a little worse. That's better. Move the other axis. That's pretty good right there. I never use just I never use what I get here. This is only to get it close. This is an import. Maybe if you had a good, a better coaxial indicator, you could maybe do that. I don't know. I've never owned anything but an import, so I just use it to get me close, and then I check it manually. So we go ahead and get rid of this. So the next thing we'll do is set up our test indicator here. And these test indicators have very little movement. This one is good at 15 thousandths. So you have to adjust it with that in mind. And I'm just going to set up my 0 on the back side. Okay. And then as I bring it back around, yeah, I'm at 0. I don't know whether I was or not. Let me do this again. Like I say, it's only 15 thousandths, so you've got to make sure. Okay, see, we're off a little here. So we're going to move our y-axis half of that distance, about right there, and then we'll put it back on the back and 0 it again. And we should be pretty close when we roll back around. Yeah, still off a little bit. So I take half of that, move it back around, 0 it out. And you get the idea. I just keep doing this until I've got 0, 0, or as close as I can. And then we go around to the sides and do the same thing. Actually, let me zero it over here so you can see. Oh, actually, it's good. Okay, so it's 0 and 0. Now what I do is I go ahead and lock my tables, lock my table locks, and my Y down here, because that's going to move things. And at the same time I'm doing this, I'll come up here and zero out my DRO. And then I'll come down and do it again. It's going to move a little bit, generally does. Yep. So I'm gonna go through the whole thing again, and then I'll zero everything out when I get it 0 again. Okay, we're pretty much 0 there. And we go around to the side and stay at 0. We go to the back and we're at 0 or just almost there. And then over to the side, same thing. So that's after we lock our table down, then we go around and when you do that and you tap on your levers here to try to get that close. And you can see here that we did move it a little bit. So we come back up and go ahead and do that. I'll set this one when I get the boring head in, only so I know where I need to start, the bore. So at this point, we'll go ahead and roll it back down. We've got it zeroed out the best that we can. And we'll get the boring head put back in. And you can see that I'll just go ahead and bring this up until I'm just above the surface here. And at that point, I can go ahead and zero out my Z, which is and that's just a close indicator for me when I drop it down and check and come back and start again with the bore. Okay, we've got this set up to, got a little drag here, starts right about here and stops right about the other bolt hole on the other side. But we don't know what the wear pattern is, so we know we've got our 0. So we're going to go ahead and take one pass and just see what it looks like with just that little bit of hitting, because a lot of times by the time you get to the bottom you're going to be hitting all the way around. So we just want to look at it, take an initial pass and just see what it looks like. Okay, let's like I say, I don't think you're going to be able to see a lot, but we'll try to show you what we can. We'll go ahead and start our first pass. We're zeroed out all the way around. Just a light cut. A lot of the way you won't even hear it. Won't cut anything probably. I think that's better for the lighting. Yeah, the ridge at the top is probably all we cut for now until we get to the very bottom. So I'll bring you back when we get all the way through. Okay, it's really hard to see, but I think we're pretty well centered. It's cutting most of the way around. It's cutting all the way around in the bottom. We've got, you know, right in here, from about here up to the ring is, you know, from about right here up, that's where your wear is. That's where the piston's changing directions and moving back down. So it's looking that way pretty much all the way around. So I think we're in good shape. So we're gonna add 2 thousandths to it and take another pass. And just to look at your piston there. Yeah, we can't even get past the ring lands yet. Now it's taken a lot of that out on this trip. Most of the way around, looks like. So at this point we've taken about 3 thousandths. I took probably 1 thousandths, maybe 2 on the first one, and then we did another 2 on this one. Not a very big exhaust port either. There's nothing big about this thing. You need tweezers to work on everything. It's pretty close over here, but it's not, it doesn't hit. I made sure of it. There's actually probably 3/16 of an inch maybe. And when we come down, we're about 1/4 of an inch off of these when we make it through. So I'll go ahead and pull it back down and we'll take another peek at it. Okay, looks like we've cut all the way down this side, and on the exhaust side we've just got a little bit around the exhaust port. I know that's blinding you. Let's see if there's some other thing I can do here. You can see there that it's a little different color up here. That's because it hadn't cut quite as much, but it's starting to cut there. And the same on the other side. So really the only place that it hasn't cut is right around the exhaust port. I'm trying to hold the camera and the light here. I think you can see that. So that'll start clearing up now. Yeah, we got a couple thousand yet probably to go. Let's take a measurement. $10 millimeters, your measurement point from the skirt, bottom of the skirt. .447. Okay. Okay. Yeah, 3/1000's where we're at before we're the same size as the piston. Okay, I'll take two more and then we'll hone the rest. Let me get set up. Okay, we're about a 0.5 away from same size as the piston. Oh yeah, just about like the other one. So we'll hone the rest of this. Okay, so we'll get set up to hone it. Okay, we've got our pistons here, and we're looking at 1.447, and they both measure the same. And I just want to show you here that when we're measuring the bottom, try it again. Okay, we're at 47.4 on that one. And 47.5 on that one. And they're both the same, or pretty much the same. I mean, what I'm trying to show you is that we didn't put any taper into it. Nothing to speak of. I've got my stones in here. These are 280 grit, and it's a brand new set because I haven't used this mandrel for this before, so I wanted to put a brand new set in it so we could start with a clean slate on this one. 1.5 thousandths. It's supposed to be 1.4 to 1.8. On to the next one. Okay, let's check the flatness of our heads here. Little 400 grit on, I've got a little surface stone here, but you can do the same thing with a piece of glass. I did for many years. And you just use the weight of the head and kind of go in a figure 8 both ways. We've got a little bit of stuff to do to it there. I don't think it's going to take very much though. And do the same thing with the top of the cylinder, just to make sure it's flat. These are probably more rusty than anything. You can see the rust coming off of them. Yeah, that looks pretty good. Got a couple little divot areas or something there, but that one there will probably interfere with the gasket. I don't know. I doubt if it's going to come out without taking a lot off. So that's what the gasket's for. Thanks, guys. And we'll just go ahead and do our chamfering here. It's real difficult to get in here on this one. Really tough to get in there. You can't even get a 90-degree one in. So you've got to do it all with the back side, the cone side of your Dremel. And once you've got them all done, you want to take care of the top of your cylinder here. I just used a little 220 emery cloth here just to take that edge off, and go ahead and feel up in there, make sure you don't have any sharp ones. If it's sharp, you need to do something about it. Everything's so tiny on it. I'm going to go ahead and take my ball hone and go in, go about 5 times to the left, 5 times to the right, and that takes care of any chamfering that I didn't get done. Usually I do the tops and the bottoms, and then I use the ball hone to take care of the vertical sides. Just small. Okay, so I'm going to go ahead and take it over and give it a quick hone. And we got our heads all taken care of. We worked the tops of the cylinders also, and everything should be good. We just I'm going to take do my ball hone, and then I'm going to put it in the ultrasonic cleaner, and once it comes out of there, I'll go ahead and paint these up. Okay guys, got them all painted up. We've got our heads ready to go, and we've got our pistons, our rings, and all of the other stuff here that goes along with it. We've got 2 new pins, 2 new bearings, and all our gaskets. So we should be ready to go, but of course that's going to have to be on another video. This one's pretty long the way it is. We got this painted and re-honed. We just, not re-honed, but honed with the ball hone. What that does is the horizontal, or actually not, the vertical sides of the ports, it goes ahead and chamfers those, and it kind of plateau hones the hone that you did first. Otherwise it knocks it down a little bit so it's flatter. I don't know, I think this is better light for you. Just kind of finishes things up. So these are set up at 1.5 thousandths, and the book calls for 1.4 to 1.8, I believe, or 1.9, one or the other. But anyway, it's pretty close, and we got her set at 1.5, or it's 1.5 thousandths, so 0.015. Okay guys, there you have it. We've got the top end ready to go on the HS1 90cc twin. It's a little bit more than 90 cc's now, not by much though. But we've got this project coming close. We're probably going to go ahead and put that in the frame and give it a whirl, just so we know. So there'll be some more videos on, we'll do a top end build, and then we'll probably put it in the frame and purge the lines and all the stuff that you have to do to get it running. And then we'll probably pull it back out and start cleaning the bike up, and I think we're going to probably paint it, and it's going to be a big deal. We've also got the GT1, the 80 Enduro. I believe in 73 they called those the GT1, but it's a GT80 also. But we've got that yet to tear down and determine what we're going to have to do, and then we're going to have to get started on it. So we've got the HS1 and the GT1, and I've still got to get the engine back in the Champion frame for the flat tracker. So we've got lots of stuff to do, lots of things going on. So I guess this was just another boring video. I hope it wasn't. It was a little different because of how small the cylinders were and what we had to do to bore them. It was a challenge, but I think we did okay. You wouldn't be able to take very much metal. You know, I don't know whether 4 thousandths would be, I I just think you'd be pushing it. You'd probably get kind of choppy in there. But taking two, and normally, you know, that's what I do anyway. I'm not in a hurry. I'm retired. I take things slow. So, you know, I didn't see any chatter or anything when I was doing it, but I did hear some squeaking once in a while. So that kind of, I think that probably tells me that it's close, and if you had a microscope, you could probably see some little chattering a little bit in there. But anyhow, I think we did okay, and once it's honed, any of that stuff's gone anyway. So 1.5 on those, and this engine ought to run like a top. It sure shouldn't be noisy. Anyhow, hey, thanks for going along on the ride. See you next video.